Okay, folks, we've just recently have covered pretty much everything that you're going to need for our polynomials tests. We've covered everything from the vocab to the adding, subtracting, the standard form stuff, multiplying, dividing, long division, synthetic division, roots, factoring, all of it. We're going to spend this entire week reviewing, and I've broken up the review into several different sections. We're going to try spending just a little bit of time each day on something different. In this first part, we're going to review the earlier stuff, the stuff that we've done on our last quiz. So it's been a while since we've done. First and foremost, here are the definitions. If you don't have them already somewhere in your notes or you don't want to find them, these are the definitions that you'd fill out. So you can go ahead and pause the screen if you need those. I'm going to simply make this video quick and short. I'm going to cover just a few of these problems with you just to kind of re-explain them to you, okay? All right, so when it comes to number 9, write the polynomial in standard form, then identify the leading coefficient, the degree, and the number of terms. All right, so standard form. Standard form is when you write the terms in order from the biggest exponent to the smallest exponent, or a better way of saying it is basically the highest degree to the lowest degree term. So if we look at our terms, we have 3 of them here. Oh, I'm going to need to, hold on a second, open up my little pen tool so I can write on this. You have your 3 terms. We're going to take those 3 terms and just rearrange them, essentially. We're not going to combine them. We're not going to try and do anything fancy. We're just going to take the 3 terms and rearrange them from the biggest exponent to the smallest. So the biggest exponent term is this x squared. So that'll be the first term, negative 3x squared. Then the next biggest exponent would be the minus 7x, because that's an x to the first power. And then the plus 6 will come last, since it has no variable with no exponent. Let's try to make my pen a little bit thinner. Okay, hopefully that's better. All right, leading coefficient. So the leading coefficient, now that we've got our standard form, the leading coefficient is kind of in the name. Leading meaning the very first coefficient, which is out here, and it's negative 3. It's always the very first number in your very first term. But of course, it's very important that you put it in standard form first before finding the leading coefficient, because it's very easy when it's in standard form, because it's the very first number that you see. Degree of the polynomial. So since we already mentioned that the highest degree is 2, or the highest exponent is 2, that is the degree of this polynomial. The number of terms we've already mentioned as well. There are 3 terms here. All right, now the name. The name comes from the last 2 parts, C and D. It comes from the name of the degree and the name for the number of terms. So when you have 2 terms, we call that quadratic. When we have, a second degree polynomial, we call that quadratic. When we have 3 terms, we call that a trinomial. So the name for this whole polynomial would be a quadratic trinomial. All right, and I'll erase it, but let me kind of fill out a little chart for you guys if you don't already have it, kind of detailing the information for the naming's sake, okay? All right, I'll do it up here where I have a little bit more space. So when it comes to degree, and its name, all right, we'll start with 0. That's called a constant. So basically, any standard number that doesn't have any variables is a constant term. It's a constant number. If it's degree 1, something like x to the first power, or 3x, or something like that, we call that linear. What we just looked at, the highest exponent was 2. We call that a quadratic. 3, we call this cubic. So something like an x to the third term. 4, we call it quartic. Oops, cubics, but it's cubic. 4th, we call it quartic. Think of like a quarter. Oops, with an R in there. 5 is quintic. I can't think of anything to compare that to. And then for 6th, 7th, and 8th degree or higher, we'll just call that a 6th, 7th, or 8th degree or higher. Okay? No special names, just stick to something very generic, 6th degree, 7th degree, 8th degree, and so on. But those are the names, okay? Apologize, again, I'm going to have to erase it just so I can get the part 2 of this with the number of terms. So for the number of terms, let's talk about the number themselves and then the name for it. Now if it's just one term, that's called a monomial. If it's 2 terms, it's a binomial. Think of like a bicycle. It has 2 wheels. Binomial has 2 terms. 3 terms is a trinomial. Again, kind of like a tricycle, but for polynomials. And then if it's 4 or more, just call it a generic polynomial. I think some people do give names to these, but for our sake, we're going to stop at trinomial. If it's 4 or more, we'll call it the generic polynomial. Now everything is a polynomial, even if it's 1, 2, or 3 terms. But 1, 2, or 3 terms has a more specific name that we're going to call it. Okay, so there are your names. Let's try number 10 just real quick as we move on. All right, so number 10, standard form. Again, now we only have 2 terms here, but we're still going to write them from the biggest degree exponent term down to the smallest. And the biggest exponent is the x to the 4th term, so we're going to write that first. Now notice it is a 9, but since the negative is in front, that is part of that term. It is a negative 9, x to the 4th. And then since it's positive, 2x to the 3rd to be plus 2x to the 3rd. So that's just rearranging those 2 terms with the biggest exponent first down to the smallest exponent last. Leading coefficient, just as I mentioned in the previous problem that we worked out, it's the very first number, the very first coefficient, in that case negative 9. Degree of the polynomial, so the highest exponent or highest degree term is 4, so this will be 4th degree, which we'll name in a moment. Number of terms, there are only 2 terms here, right? The 9x to the 4th and then the 2x to the 3rd. Only 2 total terms, which again, there is a name for. Let's go ahead and name them. 4th degree. 4th degree, we call it quartic. 2nd degree, we call, or sorry, 2nd degree, 2 terms, we call it binomial. So we're going to put those together in our full name, quartic binomial. All right, I'll leave you guys to do number 11 on your own. Let's talk about some of these adding problems, adding and subtracting. I'll just do maybe 12 and 13, and I'll leave you to do 14 and 15. So for number 12, we're adding. Now notice there's a lot of these problems look very similar, but the key to pay attention to is what's happening in the middle here. This tells you everything you need to know about what you're going to do in that problem. There's a plus sign between these polynomials, which means we're just adding the polynomials together, which in a sense is just combining like terms. So when you're adding or subtracting, all you're doing is combining like terms. It's a little different when we get to multiplying, but please pay attention closely to what the problem, how the problem is written and what it's asking you to do. So let's identify the like terms. I've got 2x to the 4th, but I don't see any other x to the 4th term to combine it with, so I'm going to bring it down, keep it as 2x to the 4th. Then, let's look for the x to the 3rd term. I got a 3x to the 3rd, and I have an x to the 3rd. Now I'm adding these, right? So 3x to the 3rd plus x to the 3rd would be a total of 4x to the 3rd. Then I've got my x squared term. It's 1 over here. There's nothing else that it's adding with, so it's still going to be plus 6x squared. Then my x terms, I've got 4x plus negative 3x. Continuing on with the problem. The x terms, 4, I have a positive 4 and I'm adding a negative 3, which is the same as just 4 minus 3, so it's just going to be a positive 1x. And then lastly, I'll do this back in blue, I guess. I've got negative 4 plus plus a positive 1, so negative 4 plus 1 is going to be negative 3. Alright, so there's your whole polynomial. There's nothing left to do. All the like terms have been combined. You've got all your terms there. So with number 13, subtracting, it's very similar. Just for the sake of having a little more space and it to not be too cluttered, I'm going to erase the previous question. For subtracting, my advice is it's as easy as adding, but you have to be very careful with your subtracting sign because you have to realize that if you're subtracting the second polynomial, you're subtracting everything in that polynomial. So what I like to do first is distribute this negative so that I can remind myself I'm subtracting all of those terms, or both in this case. So it's minus 2x squared, I'm subtracting 2x squared, and then a minus a positive 1 would be a minus 1. So I'd like to do that first and then bring this original polynomial down. And then it's just the same as combining like terms. Okay? Don't have to worry about any tricks. Everything's good to go. So you have a couple x squared terms. 7x squared minus 2x squared would become 5x squared. You've got just a single x term, the 3x. There's nothing it combines with, so it's still just 3x. We can bring it down. And then the constant terms. Negative 6 minus 1 is negative 7. So our answer, 5x squared plus 3x minus 7. So I'll leave you to try and do number 14 and 15 on your own. Okay. Now this one, I'll have to zoom in a lot here so I can get a little bit more space to write with. For number 16, it's as easy as just distributing. So distribute each of these terms one at a time. Can I make it even bigger? Yes, I can. All right, so we're looking at number 16. Distribute x term first, x times 2x, and then x times negative 3. X times 2x would be 2x squared, and x times negative 3 would be negative 3x. Then you can distribute the 4. 4 times 2x would be 8x, and then 4 times negative 3 would be negative 12. Combine your like terms and you're done. So we'll bring the 2x squared down since there's no other x squared term, but the x terms, negative 3 plus 8, will be a positive 5x, and then we'll bring the minus 12 down. And that's our final answer. Okay. Now with number 17, 18, and 19, here's my advice to you. I make a multiplication table. It makes things a little easier and a little more organized for me. So, to make your multiplication table, have one polynomial on the top and one on the side. I'll put the x squared plus 4 on the side. So x squared and the positive 4 term are there on the left. Again, it doesn't really matter if this is on the top or on the side, as long as you know, the other polynomials, the side you didn't use. So the other one's 3x squared, so I'll put this one on top. 3x squared plus 5x, and then plus 2, positive 2. So I'm just writing the terms, not even really using the plus signs. If it's a negative number, I will include the negative, but I don't have any in this case. So now I'm just going to fill in my boxes by multiplying each corresponding term. So the first box, I'm putting 3x squared times x squared, which would be 3x to the 4th. And the box below it, I'll be doing 4 times 3x squared, which would be 12x squared. Then we'll do x squared times 5x, and that'll be 5x to the 3rd. Then 4 times 5x would be 20x. Then we'll do x squared times 2 to get 2x squared, and then 4 times 2 to get 8. So that's your multiplying. Everything's multiplied. Now it's kind of like the last problems where we're adding things together. Identify some like terms and combine those. So the only like terms that you'll see are the x squared terms. So these are the only ones we really have to put together. Everything else we're just going to bring down in our answer. So we have 3x to the 4th. There's no other x to the 4th term. We have 5x to the 3rd. No other x to the 3rd terms. But we've got these like terms here. 12x squared and 2x squared, which if you put them together, a positive 12 and a positive 2, that adds to 14x squared. And then we'll bring the 20x and the 8 down. Now most times there's other like terms that we combine, but the only pair of like terms that we had here was those x squared terms. And sometimes there's more, and you just combine in the same way we combine those by just adding their coefficients. All right, that's the final answer for that. I'll let you guys do 18 and 19. Remember to use this multiplication table, try to set it up, multiply them, find your like terms, and write out your answer. All right, guys, I'm going to stop it there. We'll continue another part 2 in the next video. I will see you then. Bye-bye.